Okay, the first problem, this is the quiz, chapter 2 quiz. First problem wants us to find the line that passes through this point, and it wants it to be parallel to this line. Yours might say perpendicular, but this is parallel. So what we need to do is take this line and solve it for y. If we do that, we get negative 8y equals negative 7x plus 1. And then if we divide both sides by negative 8, that gives us the slope, which is right here, as 7/8. I want that same slope because mine's parallel. If it was perpendicular, you do negative 8 over 7. But that's the slope I want. I'm going to plug this into y equals mx plus b form, so I'm going to do actually point slope form. And here's my point, x1, y1. So it'll be y minus 12 equals 7/8 times x minus negative 2. Now, it wants the answer in this form. So this is my answer. This is a line right here. It's the line I want, but it wants it in this form. So I'm going to do double negatives go positive. I'm going to distribute. So that gives me 7x over 8 plus 14 over 8, which I can simplify to 7 over 4. And then, let's see. So I'm going to get everything on the left side now to get it in that form. So it's negative 7x over 8 plus y minus 12 minus 7 over 4 equals 0. Now, I'm going to multiply the top and the bottom of this one by 4 to get a common denominator. So this would be 48 over 4. When you subtract 7, you get 41 over 4. So I get this. Now this is the answer in standard form, which is what they wanted, but for some reason they're really picky and they don't want a fraction for your leading. They want all whole numbers for your coefficients, and they don't want a negative for the leading one. So I'm going to multiply through by negative 8 because that will clear the fractions. This goes positive. This 8 cancels, and I get 7x plus negative 8y plus 4 goes into 8 2 times. So 2 times 41 is 82. So here's my answer. It's the same answer as above. It's the same line, but it's got whole number coefficients, which is what Weber wanted. Next problem then wants us to find the domain. Now the domain comes from these intervals. I need what's underneath these radicals to be positive. So the bottom has to be greater than 0. I can't have it be equal to 0 because that'd be undefined. And then the other one, 4 minus x squared, can be greater than or equal to 0. So I need to take the most restricted domain of these two. And so to do that, I'm going to solve these. So I'll subtract 1. It gives me negative x squared is greater than negative 1. Divide by negative 1, which switches the inequality. And then square root, which gives me x is less than 1. But it also gives me x is greater than negative 1. So on a number line, if I graph that, that's x is greater than negative 1, but less than 1. So it's all the numbers in between here, which is going to be my domain because this one's going to be less restricted. If you solve this one, you get x squared is less than or equal to 4. If you divide by a negative, square root, and you get x is less than or equal to 2, but you also get x is greater than or equal to negative 2. And that one is just a little bigger. You know, it goes from here to here. So it would be a closed circle here, a closed circle here, it'd be all these values, which that's not my domain. My domain has to be the most restricted one because take a point like negative 1.5, it doesn't satisfy the bottom. If you plug in negative 1.5 here, or positive 1.5, you'll get an undefined value underneath this radical. So it's not in the domain. So you have to take the most restricted one, which is negative 1 to 1, not including negative 1 and 1. Okay, next problem then has a function here. We can graph this function, and you can copy and paste these a lot of times. This one doesn't because it's an image, not typed in. But a lot of times you can copy and paste these right into Desmos and take a look at the graph for this one, so there would be no work for this one. So if you graph this function as a cubic, we know it's a cubic. I need to find the maximums, though. So I would scroll actually way out, you know, because it's just quicker to find the maximum, which is right here. So there's the relative maximum, which is at negative 6. And then I'd scroll way out again and find the relative minimum real quick, because this will save you right there. So it's at 4. So negative 6 to 4. You can maybe draw a rough sketch of this, because like I said, it really helps to have a picture. But it's a cubic. The maximum's at negative 6, and the minimum's at 4. I didn't draw this very well, but you get the idea. There's the x value. I don't know what the y value is at those points, but I don't think I need it. Because this question just asks us, it's decreasing on the interval from, well, that'd be from -6 to 4. So from here to here, there's where it's decreasing. And then it's increasing on the interval from -infinity all the way up to the maximum, -6, and then it's also increasing from 4, so from this point all the way to infinity. Then it's got a local maximum at -6. All right, next problem wants us to find the domain of the function. So once again, the domain, we look at what our restrictions are, which we know that underneath a radical has to be positive. Normally it could be equal to 0, but in this case we can't because that'd be undefined, because it's in the bottom. So we have to have what's underneath that radical greater than 0. So I'll subtract 4 and divide by -1, which switches the inequality. Take the square root and you get x is less than 2, but you also get x is greater than -2. So if you graph that on a number line, you have from -2 to 2 as your domain, and those are open circles, so I'd say -2 to 2 like that in interval notation for my domain. And then part B wants the vertical asymptotes. So the vertical asymptotes, according to the formula sheet, occur as zeros at the bottom. So that's if you set 4 minus x squared equal to 0, which you guys are good at subtracting 4 and take the square root, you know it's going to be -2 and 2. So -2 and 2 turn out to be the zeros at the bottom, which then would be the vertical asymptotes. Next problem wants us to find the domain of this function right here. It wants the greatest value of x not in the domain. So let's just find the domain. We know that what's under here, x squared plus 3x minus 18, has to be greater than or equal to 0 because it's underneath a radical. So let's factor the bottom. The bottom factors into two linear factors probably, hopefully. Looks like 6 and 3. So we can do x plus 6 and x minus 3 is greater than or equal to 0. And now we can make a sign chart. We can do this for any inequality that we have, where we're going to put the undefined points on there, -6 and 3. These are both undefined. Now I'm going to tell whether the function is positive or negative in these intervals, so pick a number less than -6, like -7. Gives a positive in the top, a negative here, and a negative there, which makes a positive. Pick a number between -6 and 3, like 0. 0 gives me a positive there, and a negative there, so it'd be negative. Pick a number greater than 3, like 4. 4 gives me a positive and a positive, so that'd be positive. So the answer to my question, when is this thing greater than or equal to 0, would be all of these points, but not including the x, that's undefined. And then also all of these points, not including 3, because that's undefined. So I'd say -infinity to -6, not including -6, as well as 3 to positive infinity, not including 3. So there's my domain. 3 is actually the answer then, because they want the greatest value not in the domain, which obviously is right here. All these points are in the domain, all these points are in the domain, all these points are not. 3 is the greatest one that's not. All right, the next problem wants us to find a quadratic. On the formula sheet, this says it just wants a quadratic function. So the easiest function to use is what we call vertex form. The book calls this standard form a lot, but on our formula sheet we call it vertex form. Because it gives the vertex hk right there, and it gives another point, 0, 0. So I'll plug in hk, so it'll be x minus 2 squared plus 2. And then I can plug in the point that they give me, 0, 0. 0 goes in for x, 0 goes in for y. And I'll solve for a. So the -2 squared plus 2, which is just 4a plus 2 equals 0. So subtract 2 from both sides and divide by 4, and you get a equals -1/2. That goes in right here for a, and h and k plugged in with x and y as variables, and there's your answer. That's a function. It happens to be in vertex form, but it's a quadratic function. All right, the next problem gives us a parent function of x to the 1.5. So that's just an exponential function of x to the 1.5. It's right here. It says what happens if we subtract 1 outside? Well, that shifts it down 1 unit. So that'd be this one, which I think it says, it's hard for me to see that actually. Yeah, this is A, B, C, and D. So this one that's been shifted down 1 unit would be B. And then the next one has been shifted, if you subtract from x, you shift it 1 to the right. So that'd be C. And then this one is 3/2 right here. So that if you're multiplying the function by 1.5, then that would be the same as dividing y by a number bigger than 1. So that would be a vertical stretch. That would be a. And then if you have 1 minus this minus sign reflects it over the x-axis. And then you're really adding 1. So it's like, you can move it over here. That's going to shift it up. So that's going to be the last one, which is D. All this information about vertical shifts and stretches and all that is right in the formula sheet. So make sure you have the formula sheet handy for this test, because all of that information is written down for you. You don't have to memorize any of it. All right, the next problem gives us this function. It wants us to compare it to this parent function. Well, I'm going to have to simplify this. So I'm going to make it y equals 2 plus 5 plus 5e to the negative x. I distributed the 5 to both terms. And then I'm going to add 2 and 5. And I'm going to write it like this. 5e to the negative x plus 7. So that I can see that this 5 is a vertical stretch by 5, and this 7 is shifted up 5 units. So that's C. This is the vertical stretch, right? You can move it over if you divide y by 5 on the formula sheet. It says if you divide y by a number bigger than 1, then it's a vertical stretch, and adding 7 is the shift, vertical shift upward. Next problem wants us to add these two functions. So if we add them together, it's just x squared plus 1 plus x plus 1, which you can write in standard form, x squared plus x plus 2. Next one, you subtract them. Now keep in mind, when you subtract them, you want to make sure that the second one's in parentheses. G's in parentheses, so you can distribute. X squared minus x is your answer, because the 1 and negative 1 will cancel. Now when you multiply them together, you got to make sure you FOIL. So first one times g, you get x cubed plus x squared plus x plus 1. That goes here. And then when you divide them, you just divide them, so you don't have to do anything special there. This is just x plus 1. Just make sure it's in parentheses. So you do the division properly. It goes there. Now the composition f of g of x means, I like to write it like this. But you take g and you plug it right into f, so you're going to have x plus 1 plugged in right here. It's going to be squared plus 1. And you can just write that. You don't have to simplify that at all. And then the composition the other way would be g of f of x. So that means you take f of x, you plug it right in here for g, so it would be x squared plus 1, which is really just x squared plus 2. And that goes right here. All right, so some more composition problems then. F of x would be taking f and plug it back into itself. So f of x would be x squared plus 1 plugged in right there. So it would be squared plus 1. And you can write that right there. You don't have to simplify that at all. And then f of g of x means you take g of x, you plug it into f. So you're going to take this, plug it in right here. So that'd be x squared minus 1 in parentheses plugged in here. So you get that. That goes right there. You don't have to simplify. And then g of f of x means you're going to take f of x and you're going to plug it in for g. So you're going to have x squared plus 1 plugged in right here. Which gives you this. Next problem gives us this function right here, which they want me to find the inverse of. To find the inverse, you switch x and y. Now this is tricky because I got to get y by itself, so I'm going to have to multiply both sides by 8y minus 3. And then I'm going to have to distribute the x. And then I'm going to have to get the y's together. So 8xy minus y equals 3x. And move the x over and move the y over. And then I can factor out a y, and that gets y by itself. And then I can just divide both sides by 8x minus 1. So there's your inverse function, which instead of writing y, we'll write inverse function. So that goes right here. Now, the domain and range. These questions are actually pretty easy if you find the domain and range of the original function. So the domain of the original function is all real numbers except for 3/8. So I'd say all reals, x cannot be 3/8 because 3/8 gives a 0 in the denominator. The range is all real numbers except for y cannot be equal to 1/8 because that's the horizontal asymptote according to the formula sheet. It's a fraction of the leading coefficients when the exponent's the same. So for the domain and range, the domain of the original function is x cannot be equal to 3/8. That's also the range of the inverse function. So the range of the inverse would be the same thing. Because for the inverse, you just switch domain and range. So the domain of, or the range of the original function is all real numbers except for 1/8. That's the same thing as the domain of the inverse. I'm out of time in this video, so here's the answer.